This is a galaxy. Galaxies are large collections of dust, gas, and billions of stars in our universe. The bluish areas in this photo represent regions where gas is being compressed to form stars. And when those stars reach the end of their lifetime, their gas is ejected and reused to form new stars. However, when we look at older galaxies, we see a smooth, featureless image where the amount of new stars being formed is little to none. This indicates some mechanism by which galaxies are losing their gas and star formation is being suppressed or shut down, and this process is known as quenching. How and why star formation comes to an end is still an outstanding puzzle in galaxy evolution. There are multiple evolutionary pathways a galaxy can travel down on its road to becoming quenched, and we can determine which process may have been involved by analyzing the light that we observe from a galaxy, also known as a galaxy's spectrum. You may be familiar with the concept of a prism, which splits white light into a rainbow. And astronomers do a similar thing with light from a galaxy, splitting the light into a spectrum. Now, we as humans only see a small portion of the entire light spectrum, but galaxies emit light over a large range of wavelengths. In the spectra that I'm observing, such as this one, the gray region indicates the visible light portion, while the rest is in the infrared. When we look at a galaxy spectrum, we are seeing all the light from the galaxy, which is dominated by the hottest and the brightest stars, which also happen to have the shortest lifespan of just a few million years. This means that once these stars burn up their gas and die, we will see no more light in that portion of the spectrum. We can see an example of this in this spectrum, where the amount of light in the visible is less than the infrared. So, based on what light we see, we can estimate what stars make up the galaxy and the galaxy's age. From here, we can actually reproduce what the rate of star formation was as the galaxy evolved, also known as the star formation history, and notice how rapidly or slowly a galaxy became quenched to better understand what quenching process may have been at play. What I'm doing is looking at spectra for 50 galaxies in a cluster and determining their star formation history to better understand their quenching mechanisms and to further our collective knowledge of how galaxies, like our own Milky Way, will die.